Yeah, yeah. Hi everybody. So I'm Gable. My colleague here is Hong. We are from the core data engineering area. So today we're presenting about how we are trying to do StarRocks and Grab. So StarRocks and Grab currently right now is in very early stages. So the agenda for today, right? I'll first discuss, what is the current state of interactive querying and Grab. The challenges faced when we try to deal with queries regarding to BI and dashboarding, how we are trying to integrate StarRocks into our data lake, as well as present a use case on how one of our use cases where we use StarRocks to build Iris, which is our stock observability product. Yeah. So for interactive queries at Grab, right? At this point, Grab is Trino is still currently our main query engine. So we route our queries intelligently through like this Trino gateway based on user attributes such as their name, their department, or even the query themselves. If we think it's a heavy query, we can just route it to different clusters or different cluster pools. So one of the issues here is that our clusters are mostly stateless, where you cannot benefit from things like caching, you cannot benefit from things like if we send queries to the same data on the same data set multiple times, we are not able to benefit from it because there's a high chance that they will land on different clusters. Yeah, so we actually experimented with routing the similar queries to the same cluster, but for very heavy tables, generally it's not a good idea because it just cause the cluster to crash, like the cost of the coordinator. So, so now I'll discuss briefly about the BI and dashboarding. Yeah. So a couple of years back, right, we introduced Superset as part of our as a tool to do data visualization. And this actually has helped significantly encourage users to onboard and to help to uh, unlock insights for their data. So it makes it a lot easier for them to build visualizations, and a lot more users in web now use Superset to build dashboards to try to visualize their data. So as you can see, this is our Superset adoption, and as more users onboard onto Superset, right, we actually have more feedback that the query performance on the dashboarding is actually quite slow. So this is one of the problems that we're actually trying to solve here, where we want to try to improve the query performance of BI and dashboarding. Yeah. So for Power, yeah. So this is yeah. So the challenge here is how maybe try to improve the query performance for our users, right? So one of the characteristics of having like dashboard is that there are multiple charts in the dashboard, and all these charts all query similar data sets. So let's say you have one dashboard, more or less you can have like say 20 charts in this dashboard, and these 20 charts maybe query just 4 tables. In our current Trino setup, all of these charts, 20 charts will generate maybe 20 queries. They will land on different clusters. They wouldn't be able to benefit from caching or anything like that. So we also know that, let's say for heavier tables, the query patterns are known. We know that, let's say for this table, we only want to query by this, usually filter by this filter clause, or we usually do aggregates on these columns only. But this is very difficult to do on Trino side because let's say you wanted to do it ourselves, right? What would we have to do? We have to use like say materialized views. We have to pre-compute the tables beforehand, and then the users themselves will need to know what is the new table that we need to query. So all of this would all be stored in the data lake, and then the users will have to go edit a chart, go edit a data source, and then go and point to the different sources. So let's say you have like 4 data sets, then probably you will need to edit each of your charts to point to the new data source. So how do we try to solve this problem using StarRocks, right? Yeah. So the reason why we pick StarRocks for this is for multiple reasons. Like the first of it is query acceleration. So as mentioned previously, when we were doing our dashboarding, the characteristic of the dashboard is that we constantly query the same data sets multiple. So the things that we benefited from were things like the query cache and data cache, where if you were able to run a query, you will like multiple queries on the same data set, you're able to benefit because they all use pre-computed data that is already being cached. And then in terms of, let's say, trying to rewrite the queries transparently, you're able to benefit from the async materialized views, which were able to pre-aggregate and accelerate the queries. And yeah, users don't really need to know what is the underlying materialized view that they're querying. They just send the query. The query doesn't even change actually. They don't even know what data source they're actually sending to. So when they are doing the query rewrite, they just query the thing directly. And then one of the benefits of this is also the FE nodes. So for 3-node, they have a single coordinator only, and this makes it difficult for them to have to run like mega size clusters. So for StarRocks, there is multiple FE nodes. We are more confident in running mega size clusters, and if anything happens to one connector, at least we still have other connectors. Yeah. So right now we run these two query engines in parallel. So which also brings us to our next point, the unified user experience. The Trino SQL dialect here is quite important to us because users, they can just query either Trino SQL or StarRocks using the same time. So they don't really need to worry about having to learn MySQL or having to learn to SQL, which is quite important to us. Yeah. And then the last one is the data lake support, where we were able to use to have StarRocks sit at the periphery of our data lake and being able to query the data lake tables directly, ingest it, use it as a caching mechanism. Yeah. So the users, again, it's transparent to them. They don't know what they are querying. They just know that they are getting their data faster suddenly. So yeah, it's not.
I'm sorry, can you get your mic a bit?
Oh, sorry.
I can hear you very clearly.
Oh, okay.
Is it better now?
Yeah. Oh, sorry. Yeah. So this was our comparisons after we did the onboarding. So we picked the most the VIP data sets, the ones that had the most usage, and the ones that were running quite slowly. Yeah. So the latency dropped from 11.8 to 0.5 seconds. But this is with pre-aggregation and a lot of caching. So it's not really, I wouldn't say it's an apples to apples comparison, but we know the metrics is what it is. So it's not bad. So I'll pass it on to Hong now to discuss the use case of StarRocks and how we are doing this.
Hello everyone, my name is Hong. I'm working at Grab more than 5 years. More I'm working on the Spark infrastructure, using the Spark platform at the BA data analytics data scientist working on the Scala. So, and yeah, all right. Now I want to share with you more about Iris. What is Iris? Basically, Iris is we build the Iris to really deep insight on what are going on with our startup. So we collect the information about, we collect the metrics, we collect the metadata, and we build up the information to enable our user can access the Spark metric and metadata immediately instead of using the Spark UI or download the JSON file and extract that from that file. That is the goal Databricks. Iris. And one of the case is why I say it's StarRocks here, because in the new Iris architecture recently we rolled out in the last year, we replaced the InfluxDB by using the Iris, and we get a lot by using the StarRocks, and we get a lot of benefit from that. I don't know. That's why I stay here to say about what is I will get the benefit from StarRocks now. Yeah. Next slide. Okay, so before that, I want to share about what the architecture of the Iris, right? So we built the Iris 4 years ago, 2 years ago. We start to collect information from the Spark, and we get the data into somewhere to store it and allow the user to access the metrics one. before we use the TIC stack like Telara, InfluxDB, and Grafana for. We use the InfluxDB to store the metric, and then we use the Grafana for to allow user to access the metric there. For example, they can collect the information about how many CPU, what trend of CPU memory you save from the snapshot in the Grafana for. But moving forward, we see there is some kind of limitation on the existing architecture. Because we see when we have the non-use case, say the requirement from the data engineer, they want to know more than just the metrics. They want to know the metadata of that shop. For example, they want to know the job name, who are the owner of that shop, which platform running that shop, and anything, and etc. But the InfluxDB has the full limitation on storing that kind of metadata there. So I would say the InfluxDB were designed for capture the time series data, mostly a number, not for the string. So we got the issue with that. And then if we continue going with the InfluxDB, now the use case is we want to join between the metric data number, CPU say, memory say, between combined with the job name, job meta, we cannot do it in the InfluxDB due to some reasons like very performance joining for SQL queries because we need to the query designed by the InfluxDB is called look here. So it's got a lot of time we need to find another way to solve the issue when improve our system. Then we come with the StarRocks last year. So we keeping the infrastructure really the same, but we just relay the PIC, the StarRocks component. So after that, we can get the data into StarRocks. We do something we do the dashboard, we do the apply data when we serve our use case, our user using we build up the new web app to allow user to using that web app to access the data immediately instead of using the Grafana for anymore. So that means now I don't get this. Okay. So for the startup, it helps us to efficient handling the both time series data and string type data in one place. And we can do some join and optimization for that query. And then we leverage the material view from startup to do the aggregation data and access the aggregation data immediately in the data layer. Yep. This is some screenshots on the web application we do from Iris. Now from Iris, we allow users to access the job. In the job, we have information like metadata, job name, job order. We capture number of run, how long it's run, and how much is stopped as well. We do everything like this in the StarRocks layer. How do we do this? Because we capture the information right, and then we leverage the material view to do the arrangement at the data layer and request, set them as request 1 minute or 2 minutes, 30 seconds, something like that. And then in the website, in the web application, the user can access the job immediately. When they start the job, after a few minutes, they can get the data here. Yeah, that is the thing. So the key improvement from StarRocks for us is now we remove the complexity to manage the infrastructure from the TIC stack. We centralize everything into StarRocks. And now because StarRocks also help us to unlock the issue related to we want to build a web application like this. How the application can connect to database, connect to the InfluxDB very hard for the other engineer. They don't familiar with the Influx SQL syntax or the Flux syntax as well. But for the StarRocks, right, because we can connect to StarRocks using the MySQL connection. Means the user can use the MySQL syntax to do some query on the StarRocks similar to what they do for the other RDS in their web. Yeah, so it say a lot of time for learning for learning to how to use the startup to run the query as well. Another thing is Mercari will also help us to do the aggregation at the data level and also simplify how do we do the capture the information about the job like this. One of the more key I want to show out is dynamic partition in the StarRocks as well. So now we want to keep the data in 30 days. And usually for the data engineer, we may thinking about, we do some cron job to delete the data every 30 days, right? But now if we use the dynamic partition config in the startup, we don't need to do anything. We don't need to maintain the cron job or any job to just delete the data after 30 days. So we save a lot of time for engineering. And now another thing is for the low latency data ingestion. So we ingest data directly from the Kafka into StarRocks natively. We don't need any agent, Terra, anything before. We just consume the data from from Kafka and ingest to the storage anymore. So we say a lot. So I would say it helps us to say engineering work and also improve the performance as well. Okay. Next, so I will summarize some challenge we face when we use the StarRocks era. First thing, we need to ensure compatibility between the GrabPay, the Pino version era, and the StarRocks. For example, using ODE or something like that, it's not some limitation there. So, and also the secondly, the rewrite query to set event on query select using the async view as well. We need to solve that challenge as well. Also dealing with the noisy neighbor effect as worker do more ingestion queries. For example, when we do some ingestion the real data into the StarRocks, right? So worker took a lot of compute or CPU and memory to do this and affect the performance on the query side. So usually we do the ingestion new table in the hour working office hour. So yeah, that's the thing. Okay. What's next step of StarRocks Advanced? So we try to expand the scope to serve more metrics and more use case, more user as well to using the StarRocks for that use case as well. We also explore some potential use case like matrix one. We have some the matrix doing some dashboard matrix like Power UI as well, and the use case we start with the real-time ingestion. Yeah, that's the second next step as well. So for the whole summary, I would say StarRocks compatible with Chino it have and data lake have improve the query performance and reduce the learning time, learning curve and context required as well. Because if you're familiar with the MySQL query, you can be working with the StarRocks very easy. The second one is feature check, asymmetric view and multiple layer caching have improved the query performance. And it's transparent to user, as the example you said, right? So user don't care about what material view can be used. They just put query in Gino, they just query in the Supercharging, and that's it. And behind the scenes we do it. The first one is StarRocks enable the new data lake use case as well. For example, the iris use case I just said. That is all the thing we want to share with you. Yeah.